In traditional, the most common question in a math classroom was, how am I going to use this in my life? This question was so common because the traditional curriculum lacked the relation of how to use math ideas in the real world. Though traditional did ingrain math concepts into students' heads through repetition, repetition, and repetition of practice problems. Reform math makes the students realize the overall applications and uses so that students have a reason to learn the math. Discovering the purpose behind math does help the students relate to what they are learning, but this does take time away from learning and practicing the fundamental basics.
People say that the former traditional math system was grill and drill, or in that they would do these routine problems to the point where everybody just go crazy with math. Do these multiplications, do these adding of fractions, do these. Well, we're going to change all of that. Everything's going to be Sally has a lemonade stand, an application of math.
So 1,000 minus 999, okay, so you go 10, minus 1, regroup, bring it over, do that whole complicated process. But if the kids don't understand why they're doing that, then they have a tendency to make a lot of mistakes and they might get an answer that doesn't even make sense. Whereas what the reform area of mathematics would say is give the students a couple different strategies so that they can use the borrowing when they need it. But 1,000 minus 999, a student should just add on 1 and understand that the answer is 1. You know what I mean? And so that's kind of an example of where they're trying to go with thinking mathematically instead of just setting up, here's how you do it, there's one way, and nobody should think about it.
They're going to discover how to do division. What do you mean you're just going to... That's like telling a baseball player he's going to discover how to take a ground ball. No, I'm going to teach you how to take a ground ball. And we're going to discover how to do a double play. No, you're not.
Reform math stresses application problems so students can use the concepts in business settings. The idea is that students should learn approximately what the answer should be instead of relying on algorithms and calculators to give exact answers, because this allows a lot of room for mistakes.
If they're plunking something into the computer and they're not thinking about number, really, and something whack comes out of there, they might just give this person back $100 without thinking, wait a minute. Just because the computer says it doesn't mean it's true.
If students are only taught the math through an application setting, they don't transfer it well to other settings. As opposed to if they're taught the traditional, here's how you factor an equation, here's how you do long division, here's how you add fractions. Okay, now let's do a situational problem that incorporates some of that. They do well, and then when they go on to other situations, they transfer it well. What's missing in this reformed math is that first part, where here's some examples on here how you add fractions, how you do long division, how you do the routine parts of the math, and then here's the application part of it.
In order for reform to incorporate application problems and conceptual approaches to problem solving, instead of straight number computation, the books have to include a lot of reading.
If you have reading problems at all, I would imagine it's pretty challenging. Now they're going to go through, they're going to have an investigation, and virtually the entire thing is going through and having to read questions.
It's because you had to be good in verbal skills too in this new program to be able to do the math, and so those kids that could have excelled in math when they can't in writing, it was sinking them in another subject when that could have been the subject that would have been their thing.
Traditional math included more individual work, but reform math uses the idea that everything in the real world uses group work and sharing of information between each other.
And before, in individual work, when in traditional, every kid wants to, did I do it right, did I do it right, did I do it right? And I think group work just dispels that. They know when they've got it right because everybody there confirms it. And that's really empowering for the students, rather than the teacher always having the magic and the mysteries to solve, you know. No, they can do it themselves.
It comes down some to just the ability of the instructor. It can work really, really well, or it can be an absolute bust.
You can't build a bridge by yourself. So even if you become an engineer mathematically, because you're really good at that, you still have to communicate to people and explain to them and your crew what they're doing and why. So it's definitely a skill that's needed.
Math is very closely related to science and is a crucial tool for science. How is the reform math affecting science classrooms?
I think it's going to be harder for them to make the transition to more difficult math, more solid math concepts. It's going to be more difficult for them to take it from here and use it in physics, those kinds of things.
I've always deemed math as the necessary, as the needed tool to be able to do some of the things that we manipulate in science.
And so when they see a math type problem in a chemistry or physics class, they shy away from it immediately because they say, I'm not going to be able to do this. So they redo that more and more and more, and time again throughout the year, it does end up taking up a lot of time that should be spent with the scientific concepts they're supposed to be learning. I guess I've seen a bit of a pattern of that in the past 5-6 years.
Calculators are a widely used tool in the reform math books. Should students be relying on calculators so much?
It'd be 6 times 4 and I'd see a kid reach for a calculator. I'd go, what are you doing? And then I'm going to multiply it out. I go, well, with a calculator? I mean, that's killing a fly with a sledgehammer. And so at some point I realized that kids were tied to calculators for simple manipulations.
The advantage is that they can go through and they can do a lot more examples.
The traditional math books included example problems in them, so that in the case of a student or parent not remembering the correct process to solving a problem, they could look at these examples to answer the problem correctly. But the reform textbooks have no example problems, leaving it very difficult for parents and students to recall what was discussed in class.
It's difficult for parents because it doesn't look like normal. There's not examples, so parents don't know how to help their kid.
I'm talking about people who know math.
Mm-hmm.
They look at their kids' homework and they go, what are you doing?
Yeah.
And then they actually get, because they're concerned parents, they grab the book and they look back through for the example problem. And they're looking for the fundamental, where's the factoring equations and the stuff that leads up to this, and where are the things that lead, where are the routine problems that lead up, like, what's going on here?
I think it is important to allow students to see an example of the way to solve that class of problem and then let them practice that on their own. So.